We will solve this today's LeetCode problem. This is LeetCode medium. The question is minimum number of days to make M buckets. Right. So the question is you are given an integer add a bloom day, an integer M, an integer K. You want to make M bouquet. To make a bouquet, you need to use K adjacent flowers from the garden. The garden consists of n flowers. The ith flower will bloom in the bloom day I and then can be used in exactly one bouquet. Right. Return the minimum number of days you need to wait to be able to make M bouquets from the garden. If it is impossible to make M bouquets, return -1. So basically, the question is given that we need to form M bouquets, right? And each bouquet must have k adjacent flowers, right? So and the flowers we have given the bloom day, right? That this ith flower will only be blooms at the ith specific day, right? And we can only use adjacent flowers to make a one bouquet. So we need to find the minimum number of days we need to wait to be able to make m bouquets. And if we are not able to make m bouquets, we will return -1, right? So the question is simple to understand, right? Basically the question is simple to understand. Let's just analyze what the question is asking. Suppose we have to make three bouquets, right? We have to make three bouquets, and each bouquet must have k adjacent flowers. Here k is equals to 1, it means one flowers. So let's suppose we will take this example. You will be better understand, or this example you will better understand this, right? Let's take this. So in this we need to form two bouquets, but each bouquet will take three adjacent flowers, right? So what does it mean, three adjacent flowers? So if you take, see this 7 7 7, these three are adjacent, right? These three are adjacent. If we take 7 days, if I take day 7, then I can take this 7, right? But if you take this 7, then this flower will bloom, but this will not. This will bloom, right? So this, if you want to take these three flowers, so these are not adjacent, right? So you can't take this and this and this, right? You can't left 12, right? Because this is not this is in between this 7 and the 7. So you need to take this. So for this for this flower to be taken, you need to wait till 12th day. So you need to wait till 12th day. So that's what the adjacent means here, right? Simply, I hope you will understand the question, right? Basically, so one thing also, that what does it become when it become impossible to, that the m bouquet cannot be formed. If that will be possible, if m into k, if m into k, it means there are two bouquets and each bouquet wants three adjacent flowers, and m into k is greater than the number of flowers which we have in the bloom day. If this occurs, this will result to -1. We will, I'm sure of that, because each bouquet wants this number of flowers, and if m into k are the total number of flowers we need, and if it is that greater than the number of flowers we have, so we will return -1. It means we cannot make we cannot make ambukes, right? We cannot make ambukes, right? So that's the question basically. Okay. So the first thing which you should came in mind, that we want to find minimum number of days. So focus on these days. Focusing on days. We need to find the minimum number of days. How we can find the minimum number of days? The first approach is that I will check for each days. Like I will check for each day from 1 to the number of days, what can be the number of days, maximum number of days till which we can wait. The maximum number of days till each flower has to get bloom, right? So that would be the maximum number, right? That would be the maximum number. So that would, if that would be the maximum number, so maximum the maximum days which we can wait is the maximum element which is present in the bloom day, right? So that would be the till which day will I wait, right? So that would be the max days in bloom day, right? In bloom day array, that would be the max number. Till this I need to check, right? So how will you check? See, if I suppose I want I am at day, I'm at day 3, right? I'm at day 3. So if I am at day 3, right? And if I want to check that which flowers are bloomed at till day 3, so this 7 7 7 all are greater than this 3, right? But if I take some other examples like uh, 1 4 3 5 2 6, right? These are the days. And let's take ka adjacent flowers as what 2, right? And am as 2, right? So if I am at day 3, how will I check that which are the numbers, that which are the how many bouquets can we form, right? How many bouquets can we form? So if you see here, we need to take k adjacent flowers, right? So if I don't get k adjacent flowers, I will not make a bouquet. I'm sure about that, right? I'm sure about that. If I am at day 3, so this one is till day 3. This, if this flower can be bloom, yes, it will bloom, right? So we can take this, right? We can take this. So I got one flower, right? In the second day, this is 4, and which is greater than this 3. It means this flower will not bloom till day 3. It means I have not got adjacent flower, right? It means I till these two flowers I have not got any bouquet, right? It means now this count would be 0, because to recount for adjacent flowers, I need to make it 0, right? For this 3, can we form, can these flowers will be taken for a bouquet? Yes, because till day 3 it will bloom, so the count will become 1. 5, again it is greater than this 3, it will not bloom, right? 2, yeah, it will bloom, but 6 it will not bloom, right? It means I haven't got any bouquet till day 3. But what if I take 5 day 5? What if I take day 5? If I take day 5, these flowers will bloom, right? Have bloomed till that day, so that will count 1. This 4 is already bloomed, that will count as 2. So if you see, we got k adjacent flowers, that is 2. It means I can make now one bouquet. I can make now one bouquet, that would be take it as bouquet, cntb, right? Bouquet, right? So that would make one bouquet. So if I have made one bouquet to with these flowers, it means the count should be now 0, right? Now we have checked this till this. Now this 3 can also be till this 3, the flower is already bloomed till this day, right? This can be also taken. This 5 is also can taken, so this will be 1. So if you take, so if you see, these two flowers are again adjacent, and we can take this to make a bouquet. So I will increase this, and if you see, we got the number of bouquets we want. We got the number of bouquets we want, so we don't need to check that again. But uh, you remember that we need to find the minimum number of elements, right? We need to find the minimum number of. So for that, if you take 4, in this, the 4, these two can make bouquet. But after that, any two adjacent is not available which can make another bouquet. It means the 5 only can be the answer in this case, right? The minimum days which I can find is 5. If you take 6, we can also make two bouquets with these flowers. But 5 is the minimum days, so we will the answer is 5 for this case, right? This is the answer. So basically, what we need to check, what we are doing, we need to we are checking here. We are checking for each day from 1 to mx, and checking in bloom, and using that day, using that specific day using that specific day, we are we are checking that how many bouquets, we are checking that whether we can make the number of bouquets, uh, number of bouquets we can form or not. Given is we number of bouquets, we can make number of bouquets given, we can form the number of bouquets given, right or not, right? That's we need to check. And whenever I get the first day, the minimum day which where we can form the number of bouquets, we will return that. But if you analyze this uh, complexity, this days can be 10 to the power 9, right? This can be 10 to the power 9, which is a very huge number, right? And if you start doing that 1 2 mx for checking this itself is 1 in 9, which is will definitely give you TLE, right? Will definitely give you TLE. So what we can do, so if there any approach that we can do this, because if you think of shorting, then shorting will not applicable here. Why applicable here? Why? Because here orders matters, because we need to find use key adjacent flowers. Now if I sort it, then adjacent factor will gone. If I short it, the adjacent factor will gone. It means here order matter here, order matters here, right? Order matters here, so we can't do that, right? Due to k adjacent flowers, due to k adjacent flowers, right? So we can't take shorting. Another approach what we can think, so shorting will not applicable, we cannot do a brute force by checking each day. So I can one thing I can do, if I cannot choose 1 to mx, can I choose a specific day and day, and on that specific day results, on that specific day result, can I go down or up according go up, can I increase or decrease, can I increase or decrease the day according to that. So basically what I'm asking that, can I use binary search, can I use binary search here? Because I cannot check each and every day, but I need to check for a specific day, right? So can I choose a specific can I apply binary search on days, can I apply binary search on days, on days? What does it mean? That if what I will take, I will start from 0, and the maximum days which I can check is max value, which is will be in this, right? That's what from where we the that's the range of binary search. This will be the range of binary search, range of binary search, right? That will the range of binary search. So I will check the mid value, that so basically binary search what do, it will check it checks the mid value, it checks the mid value, that whether the condition satisfied, whether the condition satisfied or not, satisfied or not. And if the condition satisfied or not satisfied, we will do something, we will increase or decrease the lower value and the lower value and the high value, right? That's the we do, right? This is low and this is high, let's take it as low as high. We will do this in binary search simply, right? So basically, can we apply binary search on this? So I have shown you that at a specific day, what we do, we will simply iterate and check whether we can form this bouquet or not. So basically that would be the same approach for each and every day which becomes at mid value. So basically what I'm trying to say, that if I started from L0, let's take an example of let's take example of another let's take example of one. Okay, let's take example of the same approach, right? Let's take example of the same, right? In this the low would be 0, right? And the high would be 5, high can be 6, right? And we need to form m2 and k2, right? So the mid value would be 3, right? The mid value would be 3. So basically what does it mean? It means it is representing days, this is representing days, that can till this day I can form bouquets, right? So at three position at this say, we will check for this that with what we got number of bouquets. So till this three, I can this count is can be increased because this flower can be taken, this four cannot be taken, so it becomes zero. Now this would be the number of counts of bouquets, right? So this three can be done, so this is will be one. This five zero, this 2 can be taken 1 is 6 0 again. So if you see, we cannot form any m bouquets, it means the number of bouquets is 0. So what does it mean? What does it mean if number of bouquets is becoming 0? It means I need to increase my days, because till this day, if the number of bouquets is less than this number of bouquets we want, if this number of bouquets we got is less than number of bouquets we want, it means we need to increase our days. We need to increase our days so that I can get get enough number of flowers to make that bouquet. It means I need to increase the day. It means I need to, if I need to increase the day, what I will change, low or high? Of course low, because if I change high, this would be in less direction. So low should be equals to mid plus 1. So we will start it from 3 to 6 days, right? We will start it from 3 to 6 days. So now low becomes 4. Low become 4, right? Now if low become 4, this 4 plus 6 10, 10 by 2 is 5. Now mid become 5. So now I will check for this 5, that whether we can form this m or not. If I go to 5, this 5 is, we can take this flower, so count is 1. We can take this 4 also, the count is 2. So see, the count is equals to this adjacent k, it means I can form one bouquet. So with these two flowers I can form one bouquet. So this count would be 0 because I have already used it. Now this 3 can also be used, so 1. 5 can also be used, so this 2. Now this 2 can, this 2 is equals to this k, so I can form another bouquet, and this would become 0. Now this 2 can also be formed, so 1. 6 is greater than 5, so I cannot use this. So finally I got this bouquet. So if you see here, this count bouquet is l- equals to m, right? Is it is equals to m. It means if it is equals to m, it means I need to check for lower days also, because ultimately I need to find the minimum number of days. So if this mid at this day I can form this number of bouquets, so I need to check this lower element also possible, right? That it can be possible, and that its low days it can also be formed. So what I will do for getting lower days, I need to decrement this high. So I will decrement to mid minus 1, right? So if I do this mid minus 1, this 6 will become 4. Now this low and high, 4 plus 4 by 8 by 2, it is 4, right? Now I will check for 4, right? I will check for 4. So at 4, this can be taken, this can be taken. It means two flowers can be taken, and with these two flowers I can make a one bouquet, right? So this two flowers already used, so it's 0. Now this 3, it is can be taken, but this 5 cannot be taken. It means this count would be 0. Now after this 2 can be taken, so it will be 1, but 6 cannot be taken, so it becomes 0. So it means the count is 1. What does it mean? It means count, the number of bouquets is less than the number of bouquets we want. It means I need to increment this low, would be mid plus 1, that is 5. But if you see here, this low becomes greater than this 5 high. Low becomes greater than high, which is breaking condition, right? We cannot check now. So the answer is, so answer we got is 5. The minimum number of days is 5. So so what's the different approach between this and checking from 1 to mx further? So if you see, we are not checking each and every day from 1 to 6, right? We are not checking each and every day. We are just going in mid and checking that whether it is whether this can be an answer. If it is an answer, we will store that and check with finding the lower element. If it is not, we are changing the range. Basically we are changing the range, right? So 1 2 3 4 5, 4 and 5 and 6. So we have checked for 3 in the starting. After this we are checking only for this range, after, because this 3 is not able to make this bouquet. It means I'm sure about that below this 3 days I'm also not able to make this bouquet. It means I don't check for this 3, right? So this calculation is saved, right? So we are checking for this 4 5 6 again, right? So when we checking 4 5 6, this 5 came, right? If I got the answer, if I can make the bouquet with this 5, it means I can also make the bouquet from its right part, because all are greater than this 5, right? So it means I will not check for this because I want minimum number of days. So I will check for its lower part, that would be only 4 and 5, because we have already neglected this space rush. So what we are doing, we are reducing the space search. We are reducing our space search, right? Space reason, which where we are searching for an answer, for our answer, after each chosen day, right? After each chosen day, right? That's we are doing. That's why the binary search would be the optimal answer, right? Because why binary search would be optimal answer? Because we are applying binary search on this bloom day, right? So that would take log of the maximum, the max number which we got. So max number which we got is 1e9. So that would be log of 1e9. And you know what is does it mean? It will become 9, right? And this 9, and for each day possible, I am iterating in whole array, that would be n. So that would be n. So it means it is basically n log of m. And what is m here? M is the max number. M is the max number possible, right? That's the time complexity. Let's just try to implement it, you will better understand it, right? Definitely. So first thing is I need to just take it as a blue, right? Blue. Bloom dot size. So first thing is I need to find the max element. So for that I will use a stl just to handle this. Bloom dot begin, bloom dot end. So basically it gives us max element by iterating in whole array, right? Either you can write like this, or you can just iterate in whole loop and find the max value. It's your choice, right? We have given an stl in C++, so I'm using this, right? You can also iterate in whole array. That's the same time complexity, right? So now what we need to do, I need to make a search space, that would be mx. Maximum can be mx and lower can be 0. So this is the max, this is the search space. Now I will apply the binary search on this. So basically we need to find number of days, so I have applied days on binary search, right? A binary search on days, right? So first thing is, okay, the first ever thing I need to check is this condition, that whenever we cannot make a m bouquet, is it, this can only be possible if m into k is greater than n. So I will check for in starting point, that if this n is greater than, n is less than m into k, we will return -1 here. But the one thing you need to take care of, the uh, the runtime error. What this, that will be overflow. If you do m into k, that would become 10 to the power 5, so 10 to the power 6, and into 10 to the power 5, which is 10 to the power 11, right? So that would be out of bound of end, right? So you need to take it as a long, right? You need to take it as long. So you will just do this like that. You need to typecast this to long, right? You just need to do this, right? So that will make m into k long, and that will check whether it is get less than or equals to exist or not, right? Now first thing I need to check is mid value. Now again, the normal we write like this, l by r by 2, right? The normal we write like this, but if you see, r is 10 to the power 9 and l is 0, right? L is 0, or so l can never be 0, right? Of course. So you can take also 1, but I am taking 0 for uh, but showing this, it totally depends on you that you write 0 or 1. It totally depends on you, because the 1 is the minimum number of each and every bloom day, right? one can be the days. So basically this L plus R by 2 can give you an overflow, so it always better to write like this: R minus L plus R, sorry, R minus L by 2. So what's the difference between this L plus R by 2 and this R minus R by 2? If you add this can go to out of bound of int condition. But when you do R minus L, it will be definitely be less than int value, because 10 to the power 9 minus something will be always less than 10 to the power 9. But 10 to the power 9 plus adding something will can be go to int max value, which is out of bound of int, right? So basically, instead of instead of writing like this, always try to write like this, right? So to avoid runtime error, avoid auto bound condition, now I will check for mid value. So this check would be, so we will pass this bloom, this mid, and this k, right? And if this will give me the number of bouquet which is greater than or equals to the number of bouquet I want, it means I can now check for lower values, lower number of days, because I definitely got number of bouquets for a specific day, and I want minimum number of days. It means I need to also check for the, because this can be the possible answer, right? This can be the possible answer. This mid can be the possible answer, but I need to check for its lower values, because it can be possible that it's for its lower values the number of bouquets can be formed, right? So I will check for its lower values also, right? So this can be a possible answer, but I will check for lower values. Otherwise, if number of bouquets is greater than this check, then what I will do, I will just increase our lower value, the number of days, right? Because if if a specific day the number of bouquets I'm not able to form, it means I need to increase my number of days value, right? Now this check function I need to implement. So let's implement this check function, and after that, just we need to return answer, of course. Just make check function the vector, and this will be int, this is and bloom, this is m, and this is k, right? uh, this would be a mid, right? This would be mid. So let's take it as a day, right? Let's take it as a day. To the first thing is bloom size. So now I need to iterate in whole array bloom to check. So for that, first thing is the number of counts of adjacent flowers, and the number of bouquets, which will be take it as a count, right? The the adjacent flowers is I need to check. So for that, I need to iterate in whole array, and what I will do, I will check that whether this bloom eye is whether this bloom eye is less than equals to this current day. If it is not, if it is greater than equals to a day is greater than equals to bloom eye, it means blue this flower is bloomed already. So I will increase my adjacent part, right? Else this adjacent should be 0. If it is not, because I need adjacent flowers, if it is not adjacent, I will make this as 0. And if this adjacent is equals to k, it means I definitely make a one bouquet. It means I will increase my count, that I have made one bouquet. And if I have used these flowers to make one bouquet, I need to make the count 0 also. Adjacent flowers count 0, right? So that's the whole iteration, and at last I will return this number of bouquets I can form. Now this will check that if the number of bouquets is greater than equals to m, I will check for lower days value, otherwise for high days value. That's the total answer for this. That's the main. This is the easy one, that you need to check for adjacent flowers. If adjacent flowers equals to k, given k, you can make one bouquet. You will increase it, and this is just a binary search. Right? Hope you understand it. And I have already told you the time complexity, that we are using we are applying binary search on days. So that would be o of log of m. M is the max number of days. M is the max number of days, right? And for each day I am checking, I'm iterating in whole array. That would be n into log of m. N is the length of array, right? So that is the space complexity, and that's the time complexity. And what is the space complexity? That would be O of 1, because we are not taking any extra arrays or any extra spaces here. We are only using only using variables. This will also take O of n, but if you see this O of n log n plus O of n, that will ultimately be O of n log m only, right? Because that is bigger. So that would O of n log m ultimately. So yeah, this is how we'll solve this question. Hope you understand. Thank you so much. Bye bye.